Hello, welcome to Business Statistics. In this lecture, I will discuss measures of dispersion. In this, we are looking for spread or variability in a data set. So different measures of spread which we will learn are range, variance, and standard deviation. So range is largest value minus smallest value. For example, if we have a data set three, 12, 20, 15, 0. So the largest value in this data set is 20 and the smallest value in this data set is 0. So the range is 20 minus 0, which is 20. So what this is saying is our data set is spread over 20 units. So then the other measure is variance, which for population is represented by sigma square. So the formula for variance is summation of xi minus mu, which is population mean, whole square divided by n. So this symbol is summation. This represents each data point. This is population mean, and this is population size. So the variance for sample is represented by s square, which is summation of, so it will look same as population, xi minus x bar, which is sample mean, whole squared divided by n minus 1. So again, this is summation, this is each data point, this is sample mean, and then this represents sample size. So the next thing is standard deviation, which is square root of variance. So that means if I do square root of sigma square, which is for population, it would be sigma. So the standard deviation for population, as we discussed earlier, would be represented by sigma. Similarly, for sample, it would be square root of s square, and that is s. So it would be for sample, it would be s. So that's the concept of variance and standard deviation. So we will use a data set to understand what each of these formulas exactly mean. So this one and this one, what they exactly mean, we will use a data set. Suppose we have a data set three, 12, 20, 15, 0. So to calculate variance, one of the things is it a population? Is this data set a population, or it is a sample? So let's assume that this data set is population. So I will draw a table that is data So here we have data, and then we have deviation So the deviation is represented by xi minus mu. So where mu is population mean, and then we have deviation squared. So that means xi minus mu whole square. So our data points are 3, 12, 20, 15, 0. So as such, if you see variance, if we wanted to calculate variance or standard deviation, what we are saying is how much each of these data points, which is xi, is deviating from the mean of this data set. So we wanted to calculate the mean of this data set, mu, which is the average of this data set. So that is 3 plus 12 plus 20 plus 15 plus 0 divided by 5. So this is going to give us 10. So we are calculating the deviation of each point. So we have the 3, so we have to subtract it from 10. 3 minus 10 is going to give us negative 7. So 12 minus 10 is going to give us 2. 20 minus 10 is going to give us 10. 15 minus 10 is going to give us 5. 0 minus 10 is going to give us negative 10. So once we got deviation, we are more interested in calculating average deviation for this entire data set. One of the questions we might ask ourselves is, why don't we just take the average of these deviations? So if you see, if we add them and divide it by 5, the problem is the deviations, negative values and positive values, they add together and we end up with much lesser deviation, even though we have deviation. So in order to avoid that problem, we square each one of them. So that's the reason why we are squaring it. So when we do negative 7 square, we get 49. And then when we do 2 square, we get 4. When we do 10 square, we get 100. 5 square, 25. And then negative 10 square, 100. Now we can take the average of these values, so which is 49 So we can do the summation and divide it by n, plus 4 plus 100 plus 25 plus 100. So this is going to give us 278. So if you see our formula, sigma square is equal to summation of xi minus mu whole square divided by n. So this xi minus mu square is what we did in this table, and then summation is this part, and now we have to divide this by n, which is, in this case, n is capital N is 5 because we have 5 data points. So this is going to give us a sigma square of 55.6. So this is 55.6 is our variance. And if we want to calculate the standard deviation, we have to do square root of variance, which is sigma. So square root of 55.6 would give us 7.45. So for sample, if we wanted to do the same thing, so for sample, if we want to do the same thing, if you see mu is replaced by x bar, so the mean will be the same. So here, if this is the data set and we are considering this as a sample, then this will be x bar. So that means x bar will be 10. So this column, this whole column would be same. That means if we square them, because we are squaring each one of them, the deviation square column will also be the same. That means our summation 278 would also be the same. However, the difference in the formula for variance of a sample is, it's all same, summation of xi minus x bar whole square divided by n minus 1. So here our n, small n, is still 5 for samples. So n minus 1, so this one becomes 4 for sample. So that is for sample 278 divided by 4 is going to give us 69 8.5. So that's our sample variance. So if we do square root of 69.5, we should get a sample standard deviation which would be 8.33. So if we observe population variance, which is 55.6, and sample variance, which is 69.5, we see sample variance is large. Similarly, standard deviation is 7.45 for population, and for sample it's 8.33. So we see sample standard deviation is higher. So one of the conclusions which we can make for a given data set or same data set, population variance will be less than sample variance. Population variance will be less than sample variance. So this concludes our lecture on measures of dispersion. Thank you.